Hey everybody, Dave Lindbergh in Hong Kong. Cloudy day here today. Another episode of THD Podcast, and this one we have a Audio Loudspeaker Technology Institute member joining us today. This is, I think, their second visit to the podcast, but Institute for Audio and Loudspeaker. A lot of people might know them as ALMA. So, to introduce that, it is Tectonic Audio Labs, and as always, our co-host from Japan, Mr. Simon Weston. How are we doing today, Simon?
A little bit chilly over here, Dave, but I hear that Tim's going to go hard and deep, so looking forward to that.
All right, so we've got everybody on either clicking away of their computer instantly, or sitting down for a nice session. I don't know which way it might go, but Mr. Tim Whitwell calling in from Tectonic in the Seattle region. How are you doing today, Tim?
Yeah, I'm doing good. Thank you, Dave. Yeah, it's a sunny day here, which is we take it when we get it. So,
okay. So to preface this for everybody, we've talked about some of the products technology-wise that Tectonic brings to market previously, but there's I guess some marketing effort coming up from Tectonic in terms of the application of the BMR drivers in a particular product category, and so in preparing some of that, Tim and I had some discussion on it, and it quickly became something that sounded very exciting to talk about in terms of explaining details about the podcast. So what we're talking about today is a market segment called Unified Communications. Other people might know it as just conferencing speakers, those classic kind of Polycom devices you see in the center of an office. But now with everybody working remotely and such, this product category has kind of exploded in the last 12 months. And so we wanted to talk to Tim today about what makes these things so great, or BMR so great for use in this. So where should we start, Tim? I think...
Just a quick kind of addendum as well. I mean, what we see in the UC space now is, not just like the tabletop conferencing devices. I think you mentioned like the Polycom ones are pretty well known, but it extends into things like sound bars that go underneath a TV in a conferencing room. So you've got the people on the screen and the sound bar underneath, or could be sound devices down the sides, and it even extends into things like ceiling speakers now as well. So there's again, it's filling the conference room with the audio. So it goes from the domestic level, people at home on their computers, to conferencing systems, small rooms with just a little desktop device, to bigger conferencing rooms with sound bars and ceiling speakers. So it's a pretty broad category now.
So I guess the theme is there people aren't just huddled around this single speaker. It's getting even more complicated for people to be hearing this audio. And I think that's a good segue into why the BMRs can be effective. And we talked about the sound power level a lot in preparing this marketing effort. And so maybe we can discuss a bit about the sound power level and how that differs from the sound pressure level that most people use as a measurement tool.
Perfect. Yeah. So sound power level is something that we've been kind of pushing quite hard at Tectonic, because it's probably the most representative way of capturing the total radiated energy into a given space. And so what you're doing essentially is making sound pressure measurements at points that cover like a hemisphere around the device under test. So in the case of Tectonic's anechoic chamber, we have a 19 microphone array. So that's 19 microphones spaced 5 degrees from 0 to 90. And so we basically can put a drive unit or a speaker on our platform, a baffle that's connected to a turntable. And then we can measure with all of those 19 microphones, all the angles, 5-degree resolution. Then we can rotate it 5 degrees, measure again, rotate, and so on. And that way you build up a hemispherical map of those kind of sound pressures, and then you can combine them together into what's called the sound power level, as you mentioned, which is a relatively straightforward process, but you do have to, it's not just averaging the pressures, because you have to account for the area through which each radiates. And the microphone that's directly above sound's going to come through a little tiny circle at the top of the hemisphere, but the microphone that's out here is going to be the sounds coming from a whole strip around the circumference of the hemisphere, the sort of virtual hemisphere that we've created. So again, you have to apply some weighting there, but again, relatively straightforward. But what you end up with is you can either look at it as like a heat map of the sort of pressure field over the hemisphere, or you look at something like the sound power response, sound power level response curve, which looks like a frequency response curve, but it's, as I say, it's integrating all of those individual points. And so it tends to have more of a sort of sloping down trend towards higher frequencies, depending upon the device. And as we know with most speakers, the directivity tends to narrow as you go to higher frequencies. And so therefore you're getting less power radiated off to the sides. And so you want to see that level kind of drop as you get to higher frequencies. And then, as you say, that kind of naturally sort of leads into, why, for example, a BMR would be a good solution for conferencing speakers. So if we start with that kind of simple tabletop concept of a device in the center of a conference table, and you have people, typically all around it. And so this is a good example because in many of those systems, there's a single speaker in there, maybe upfiring. Okay, so again, a single point SPL measurement is not that helpful when you've got people all kind of sat around it. So knowing how that device radiates in all directions is extremely helpful. And this is one of the features, key features of our BMR drive units, is that they have a smooth and extended sound power response across the whole range. And that's something that can be quite unique. And there are other plenty of full range drivers out there, but a natural feature of a BMR is that we balance that sound power response so it's always smooth. And essentially what we're doing is we are using the bending wave modes in the diaphragm to our advantage and balancing them out so that we get this uniform smooth radiation pattern. And interestingly, it often extends into the ultrasonic frequencies. And this is something, again, that the UC, Unified Communications field, is becoming interested in now. Because, again, you think about having a device where you can do gesture control. So the ultrasonics can maybe detect your hand movements for volume control things. But perhaps more usefully for the UC area is being able to sort of ping the room and maybe identify where bodies are, with an ultrasonic kind of almost like a sonar ping, but in the ultrasonic domain. And again, that's something that most of our BMRs have kind of automatically built in anyway. So having an upfiring device in that sense that has a uniform, smooth radiation pattern and sound power response is probably the best way of getting the highest intelligibility, most natural sounding speech that you can from any system. So that's where a BMR would be a great starting point in a system like that.
And how unique is that? Like, what's the relative comparison? Like, if somebody goes, "Nah, I don't need that. I use this regular speaker." Like, how close could they get with using other electronics or other methods? And then that kind of parlays into how the single unit versus what I understand you eliminate the crossover becomes effective as well. So what's the other way to do it? Yeah.
Yeah, absolutely. So, I mean, obviously electronics and DSP now is very commonplace, but, you can't, with DSP, you can't fix something at a particular angle in a drive unit's radiation, because when you apply the DSP, you're applying EQ boost, in a certain region of the response, but that's going to be driven into the whole drive unit. So all angles are going to be changed by doing that. So what you often find is that a speaker, maybe starts rolling off above, 5, 6, 7 kilohertz. And so you may want to boost the response to level that. Or actually, probably a better example is, let's say we're looking at 45 degrees off axis, which is where somebody may be sitting or standing on that conference call. The problem then is that if you adjust the equalization so that they get a good response, somebody that's a bit more closer to on axis is going to be getting a very, very boosted high frequency response that will sound unnatural and probably a little bit harsh. Now, again, someone may not be standing in that location, but that energy has now entered the room in a way that's, not a natural proportion of energy. So it's going to detract from the experience and from the intelligibility. So there's that aspect, and then as you say, obviously the BMRs in most cases we are offering like a full range driver solution or a mid HF approach. Obviously, a full range driver eliminates the need for a crossover, but in a two-way device, you have to have a crossover, and this is one of the issues that you come up against with the sort of conventional technology out there is that the tweeters, the physics of tweeters means that they have to be crossed over somewhere between 1 to 3 or 4 kilohertz. And unfortunately, that's the region where the human hearing system is most sensitive. And so, there's all kinds of anomalies that can happen in that crossover. And again, you can do the crossover so it works great at one position, but then it may not work so great at another position. And again, we have a room of people standing around. How do you guarantee it works for everyone? And there's a hell of a lot of engineering effort that can go into making that crossover as uniform as possible. And you may never quite get there, because one of the other issues that we commonly see here is that the separation of the units, the tweeter and the mid-bass driver, for example, that separation, that distance can be about the same as the wavelength at the crossover point. And that really makes the crossover challenge very difficult to do. You think about the wavelength at, say, 3 kilohertz is the order of 10 centimeters, and that may be the separation of the two drive units. Whereas, what we kind of promote a lot with the BMRs as kind of mid-HF devices is at that point you can cross them over at 300 hertz or so, where the wavelength is over a meter. And then if the two drivers are separated by 10 centimeters, doesn't really matter. They're effectively coaxial to a large extent. So, that lowered crossover ability kind of solves those issues. Or as I say, you use a full range BMR.
So when you said a crossover with a mid HF driver to something else, you mean there's a bass driver as well?
Yeah, if you wanted to have, say, extended low frequencies or something like that in a two-way system, then then in that case I'd use like a mid HF type BMR and cross it over to that bass driver. But you'd cross it over, say, 300-400 hertz or something where it's really not an issue.
Yep. And let's say if you're taking the example of a bench top desktop unit with a speaker up firing, is that a valid example?
That could be one example, yeah. I mean, it could apply to sound bars as well. It could apply to ceiling speakers.
Okay, in that case, though, like say the sort of like a teleconferencing speaker, do they generally need anything lower than 300 hertz? Is that not already covered well enough?
They certainly historically they tended not to necessarily go that much lower. But again, you do lose some of the warmth of certain vocal ranges in doing that. So often there is more now a push to go lower in frequency, at least a bit lower, and just capture a bit more of that natural speech sound.
Right. So you just get a more natural sound out of it if you do have bass extension, essentially.
Yes.
Cool.
Yeah. Of course, that there's a trade-off there as well. So in a sense, you have the microphones that are working hard to try and capture everyone's speech within the room. But of course, once you start having, lower frequencies in your system, that can cause a lot of vibration within the structure or the enclosure of the speaker. And those vibrations can couple to the microphones and create distortion problems for the echo cancelers and so on. So again, there's always a trade-off there. And again, when you design your low frequency side of it, you have to, pay a lot of attention to that, as well as, where the microphones are positioned and how they are mounted to isolate them from some of those vibrations.
Yep. Okay. And so that's another point in terms of the echo cancellation. This is normally part of like a Zoom or a Skype or whatever the PC is doing that job. Does using a BMR have any influence on that, positive or negative?
So we don't have any objective data at this point on that. We only have some anecdotal experiences where we've kind of played with systems in a room, and I guess the classic one was trying to get the wake words with a smart speaker, trying to get the barge in. So you've got the device playing music. You're standing in the far side of the room, and you say hey device, what's the weather today? And we've anecdotally seen some cases where the BMR system was more responsive. And again, we don't fully know yet. This is an area of ongoing research for us, is what exactly is going on there. One of the things that we potentially see is certainly with two-way devices, when you have the crossover, in that kind of critical region, the phase shifts and the crossover can also cause issues for the echo canceller and stuff as well. So going to a full range solution at that point might be a better option.
Kind of feel intuitively with a more even power distribution from the speaker that effect would be enhanced essentially or more effective.
Yeah, and that's exactly, again, that was the other thing that we kind of postulated there, is that if you're off axis to the speaker, if it's a traditional speaker, most of the time when you're off axis, certainly at the higher frequencies, you're not getting as good a sound level, and so you have to turn the device up more. And so what that means is that the device is working harder, which means there's more distortion coming from the drive units and perhaps from the amplifier as well. Of course, the microphones then are seeing a higher SPL, so they're driven closer to their overload points. And so the whole system then becomes, less stable potentially. Whereas with the BMR, given that the off-axis is often as, very close to the on-axis in terms of level, people don't need to turn it up so much. And so the whole system is more relaxed and more effective.
Right. And so like now that these systems are going off the desk and as a, conference room soundbar and sound pressure, I remember with the early introductions of the Alexas and the Siri, or not Siri, but Google assistants in the soundbars, the factories making it was very challenging for them to get that to work. So I guess in general, like you might be putting larger BMRs into those soundbar type systems as people move them into the side of the room and further away, with people having to hear from kind of obscure angles that aren't facing the desk.
Yeah,
right.
And the other thing we see, and again, you'll see this in some of the older kind of conferencing speaker systems, is that they often use multiple drive units. Again, maybe pointing in different directions to try and give everyone the coverage they need.
Yeah.
And again, if you can achieve that same coverage with a single unit, not only is it more cost effective, but also you have less acoustic interference, because those three units are going to be, due to path length differences to people in different locations, they're going to get, a certain amount from one and a certain amount from another. And because there's a slight difference in distance between the sound from those two different drive units, there's going to be an interference effect. And again, so a single acoustic source is always preferable in that sense because of those kind of interference effects.
So you guys sell the raw drivers, right?
Yes, that's correct.
Yep. So your customers are people who are building products that integrate microphones, electronics, and then your driver?
Yes.
What skills do they need to have to make use of the drivers? Is there any quirks or special abilities you need, or just a regular stuff it in a box and away you go?
No, a really good question. So a little bit of both. So in one sense, the BMR drive units work just like certainly at low frequencies, work just like a regular drive unit. So you put them in a box, you can tune them with ports or passives, EQ, everything exactly the same as you would normally do. The only caveat I would say is because the BMRs have this very wide off-axis output, wide directivity output, you have to be a little careful in terms of how they mount into the baffle. You obviously don't want to recess them too far, because then you're going to be acoustically shading certain angles, and it will interact with because there's so much more energy coming off axis, it will interact with the local baffle environment more strongly. So there's a little bit of making sure it's little flares or kind of rounded edges. Not necessarily a full-on waveguide, but that sort of not having sharp edges and recessing it too far. Those are the main things to worry about. But they haven't been issues for any of the customers we're currently working with on that.
So do you still publish like TS parameters to help people design an enclosure?
Yeah, absolutely. So all of our data sheets for the drive units come with the standard TL small parameters, and obviously they'll come with some power handling information. Where recommended high pass filter for the power handling setup, and then measurements of on-axis SPL, impedance curve, and the sound power response as well, normally too.
I want to just jump back to the point that you mentioned earlier about the sound power level response having a downward sloping character. Is that in any way different to regular loudspeakers? And how does that actually come across in terms of being a natural sound? Is that not perfectly natural?
Yes, and actually a certain downward sloping trend is actually desirable, and that's what's been determined. I think there's plenty of AES literature on it as almost like the sort of the most natural balance for most people, because when you're listening to a speaker, of course, you're not just hearing the direct sound, you're hearing the reflections off the nearby surfaces, and so it's important to kind of factor that in as well. Yeah.
In terms of room response type of thing, that's still a constant that you can't really have any influence over.
True. I mean, of course, every room is different, and that has a big part to play. But again, if you know that total energy coming off your drive unit is of this kind of natural smooth character, then you know whether the reflections are strong or weak. At least the general character is going to be, nothing's going to be sticking out too much and causing response anomalies or intelligibility issues.
Mm-hmm.
Yeah.
And power handling amplifier side, it's the same deal.
Just the same, yeah. Absolutely. Yeah.
So it can be a drop-in replacement for somebody who's got an existing box.
For sure, yeah, absolutely. And again, as just kind of going back to a point you made earlier on that, obviously we publish data sheets for all our drive units, but we also provide engineering services. So again, depending upon the level of competency, some of our customers are new to this field or have come from traditionally other areas. And again, we're always happy to look at how we can support best with measurements, advice, engineering, even sometimes down to the ID level. We can provide advice there too. So
to give them an engineer's ID, a nice rectangular box with big screws.
No, we have our VP of operations is a very, very talented gentleman, and he actually has some real chops in that area, and he can create renders and so on to give customers some idea of what it might look like. Just like we often will produce a 3D printed enclosure, drop our drive units in, use one of our off-the-shelf amplifier EQ solutions and send that to a customer so they can get a feel early on for what their product might sound like. We can also do the renders, ID render side to give them a feel for what it might actually look like with the real paint finish and so on. Now, that's not necessarily our core competency, but it's something that we have offered in the past, and some of our customers have actually really found that beneficial. Yeah.
And are people asking for custom driver, like they want a very specific dimension, something to fit a particular space, or does it tend to be standardized sizes?
Yeah, I mean, we do obviously get sort of requests as well. Of course, the easiest for us is to use something off the shelf. But again, if the customer is either significant expected volumes, or we also do offer NRE type services. We can design a custom unit to suit any particular application. Yeah.
I guess. I mean, is there much demand for that, or standard sizes quite flexible? I mean, cover the range.
Yeah, I mean, often it's sort of an in-between. Often the customer will say, we really like this unit, but we want to change a couple of things. And again, for us, it still means we have to create a new part number and all that kind of thing. So it's completely separate through our kind of operational chain. But in terms of the engineering effort required, depending upon the changes they're looking for, it may not be a big engineering effort.
Would it be fair to say that the tuning of the BMR effect, what do you call that? The dispersion effect is diaphragm level?
Yes.
So if you wanted to change your frame sort of mounting or something, then that's fine. That doesn't affect it at that level.
Yeah, changing things like the basket frame and that kind of thing generally doesn't have any real impact.
Yeah.
Often it's a case of, they may want to increase the sensitivity, and it may be we use increased magnet grades. Again, that nominally wouldn't change the balancing at all. It would just give a slightly higher sensitivity, for example.
Yep. And this term, unified communications, can you explain that a little bit? Because this is the first time I'm hearing it. Why is it called unified communications? Is it just a grandiose term, or is there...
Yes, good question.
I think so.
I assume it's kind of unifying people and
unifying the people. Yeah. Okay.
But that's just because I'm the marketer in the room here. It's kind of a snake thing to, snake oil is sold out, so we have fish oil now. So they just kind of come up with a new name, create a new category. Now everybody needs it, rather than, oh, we already have a conference speaker. Oh, but you don't have any unified communication.
Is there really some design correct characteristics or performance characteristics that make that differ from a regular music or movies type speaker?
For sure. I mean, it's, again, this is something that we've seen, in the past working on, say, speakers for TVs. In that scenario, you often want to slightly accentuate the speech region of the bandwidth, because often people will say, I can hear the music and the explosions, but I can't hear the speech very clearly, right? So again, a TV, most of the time, it's the dialogue is the most important bit. So, and again, with a conferencing speaker, of course, speech is predominant. And again, you might end up with some response shapes a little bit that might look a little unnatural for, let's say, someone listening to music, but it might provide the highest intelligibility over that bandwidth. So there are sometimes some adjustments there.
Yep. And an old-fashioned style of voice communication was quite limited bandwidth, but not really the case anymore. But do you think that it's still beneficial to have a bit of a rolled off high frequency because things get a little bit too digitally at the high frequency?
Absolutely, and we see that in some of the products that we've kind of torn down and analysed. We often see very, very steep low pass filters at the top end to kind of to help with that, for sure. But at the same time, you exactly as you say, right? The previous telephony standards, maybe you have 300 hertz to 6 kilohertz or something like that, was considered acceptable. But what we're seeing now is that, there are certain sounds in human speech patterns that actually can't be fully reproduced with that limited bandwidth. And certainly, I forget the term. It's not, maybe it's plosives, but certainly sounds like S and F.
Yeah.
We've actually measured this in our anechoic chamber, just somebody speaking into a microphone, and we see a lot of energy content up to like 14, 15 kilohertz, just saying those letters. And so again, if you want to really truly capture the speech so that someone at the other end can clearly understand what you're saying, you probably need to have bandwidth, good bandwidth up to at least 14 kilohertz, really.
Right. Because there was this thing where, like you say, there was a standard, 300 to 6K, whatever it was, would be the voice range. And I'd kind of got the impression maybe some people had misinterpreted that as being the optimum rather than being the minimum requirement. Do you think that's a valid point of view?
Very, very much so. And I think it was probably that initial kind of limited bandwidth was probably chosen because of the limited data rates that were available at the time. Data transmission rates, and
right.
Now we can send real-time video and audio in high resolution 4K, whatever, no problem. So I think that's probably where it came from.
That's very good.
Okay, that's you didn't have any chance to get any of those charts of the sound power level prepared? Maybe we can have a look at those.
Yeah, if I can share my screen.
Give you the power. There you go.
Yeah. Let me pull up a couple of things. Here we go. Where's the share screen? And go for.
So developing the sound power level measurement, you mentioned you have 19 microphones in a hemisphere, and then you rotate the turntable and generate what must be hundreds and hundreds of frequency responses.
Yes, we have, so 19 responses, and then I guess another 36, 72. So whatever 19 times 72 is. It's a lot of data. But again, we have a fully automated system now, so you can essentially press all of, have a little front end where you type in what resolution you want and everything, and it press the button, close the chamber door. Come back an hour later and you've got all the data. And actually, we now have one of our engineers is pretty adept with software, and he's actually written some scripts now. So that's all in C#, and automatically loads it into our measurement processing packages as well. So it's all ready to go. So it's a pretty slick operation now.
Yep. And for measurement, what type of test signal do you use? Would you use a chirp
Yes, tend to use a log chirp. Yeah.
Yeah. Okay.
Most of the time. Yeah.
Okay, maybe
Can you
go
see
full
my-
screen. Just
Yep, we
turn it
can.
to full screen, and we should be able to see it a bit larger for everybody.
Yeah, I was.
That little
It seems to have
icon.
made it full screen on my other screen. Hold on.
Yeah, I think you just
Too
hit
many
that
screens.
Let me see if I can share a different screen. Hold on, I think we want this one.
There we go. Perfect.
So yeah, this is actually showing one of our recently introduced BMR drive units, the 54C. It's about a 3-inch size. So actually, this part number you see up here, I meant to change that. Sorry. So typically, the number after the C means circular, because we actually have square and rectangular drivers as well. But the number following that is typically the power handling. And actually, this unit has been measured up to 30 watts power handling with a 150 hertz high pass.
Yep.
So I need to update that. But yeah, generally, so here you can see on the graph on the left-hand side here, this is the sound power response measurement.
It's is it an IEC baffle type measurement?
Yes, we typically use the IEC baffle. It's about 1.25 meters by 1.25 meters.
Okay.
What you typically see in like an on-axis response with that baffle is a fairly large dip around 400 hertz. When you look at the sound power response, because it's considering all the different angles, it tends to get averaged out. You can see a little bit of a feature there at 400, which is the remnant of that baffle dip. But the key takeaway here is obviously this downward sloping trend, which we talked about, but also notice how everything is generally very smooth across that as it rolls down there.
Yeah.
And you can also see that we're actually extended the measurement up to 40 kilohertz, and so you can see there's really good output there up to at least 30 kilohertz. And in fact, you can see that on the polar response shown here to the right. So you can see we've picked a few frequencies. So you can see obviously 1 kilohertz in red, 5 kilohertz in blue. Nice 180 degrees directivity, but you can see that's generally preserved even at 10 kilohertz, 22 kilohertz for the purple curve. And what you see in the black curve there is at 33 kilohertz. And again, it's impossible. Well, it is impossible for a piston-based speaker to do anything like this. So this is really, really powerful little unit. And what I can also do.
Can I ask you something about this response?
Go ahead.
Just taking it as though it were a frequency response, so it's sort of rolling off from about the 300 hertz region. Is that the limitation of the IEC baffle in terms of its baffling capability? So you put down the FS at 145. If you had a true infinite baffle, would that level be more or less up at the 95 dB?
Yeah, that's right. I think at the minus 6 dB would be around the resonance frequency.
Okay, -6. So actually, no, it would look similar to that if it was in a true infinite baffle, is what I'm getting at.
In a true infinite baffle, it would probably be a little smoother at the bottom end here. Some of the ripple and so on is from the finite size baffle, and again you are losing some low frequencies because of that finite size, for sure. So you'd expect to see a bit more extension at the bottom end. It's worth noting that actually in system you can actually go quite a bit lower. Something I'll show.
That's actually what I'm angling at. So you put it into a box with a reflex port.
Yep.
What would you see? You could actually go down to almost 100 hertz at -6 type of thing.
Yeah, you can go. I think it's almost to 80 hertz -6. I actually have another thing if I can share my screen again. So we actually have been working on a. Showing up earlier. Give me 2 seconds.
Is there any distributors? Somebody selling these one by one? Can I buy one?
At the moment, we're only just kind of releasing it for mass production at the moment.
Okay.
So at the moment, best bet is to contact Tectonic if you'd like samples. But we typically do make these available through some of our distribution partners. People like Parts Express and.
Parts Express then. So not specifically this driver, but other Tectonic drivers. I can jump on Parts Express and buy one piece.
Absolutely, yes. Yep.
Yeah.
Okay.
So it's asking me to move this window. Can you see the ceiling speaker?
Yep, yeah. I sure can.
So this is wanted to show you an implementation of this drive unit. So this is a ceiling speaker that Tectonic has been working on. Again, I can't say for fully at this point if it's going to be a Tectonic branded product or something that we might look to white label with other customers and so on. But at the moment, we built a prototype and the performance is really excellent. And just to your point on the low frequency side, you can see it's got a port here, a rectangular port, and we get minus 10 dBs, about 70 hertz, minus 6 dB, 80 hertz. So minus 6 dB at each end is basically 80 hertz to 15 kilohertz for this particular unit. And actually, I've got a nice measurement here. So there's absolutely no equalization being applied here. This is the drive unit in that box, mounted in a ceiling, and then measured over a range of angles, again, for that sound power response measurement. And so you can see, this is extremely smooth and extended from.
We're not seeing that plot.
Oh, you're not. Oh, hold on. Let me.
There we go.
Can you see? This is the plot with the impedance curve and everything as well,
yeah? Yeah.
Yes.
Got it.
Great. So sorry, apologies for that. So now you can see basically the sort of 70, 80 hertz all the way up here to beyond 30 kilohertz. Really, really smooth response. So what this means is that almost wherever you stand in the room, you're going to be getting, a really good experience, and what we find is that, a lot of the ceiling speakers that we've been listening to and measuring, often, there's some boosting of output or, in the way the driver's designed, trying to kind of push their off-axis energy as much as possible, which means that when you walk underneath it, when you're kind of in that cone, let's say, 10, 20 degree cone directly below it, it literally cuts your head off with the high frequencies.
Yeah. I know exactly what you're talking about. It's brutal.
It is, yeah. And honestly, to experience this Tectonic one is really lovely because it's just really smooth and natural everywhere throughout the room. And I would say that, of course, but I genuinely invite, hopefully people will be able to purchase them and try it for themselves as well.
Yeah, I think just on the ceiling speaker install, there was something I saw today about the Metro line in Sydney installing the BMRs in the ceiling in the tube stations there.
Yeah, we just that was a really interesting one. They were looking to improve the intelligibility for like platform announcements and so on in some of the Sydney subway. And there's a really nice clip. I think it's certainly on some of our social media posts comparing the sound of the system, the previous system, and then the system with the BMR speakers in place. And it's a night and day difference in terms of that whole kind of echoing down the platform and so on, and intelligibility.
Cool. Well, hopefully this COVID ends and we can maybe get out to some of these train stations or airports and hear some BMRs. That's a whole other topic outside of unified communications.
I know. If I could get on a plane to Sydney right now, I'd be there in a shot.
Yeah, it's. I guess they're fall. I don't know, Simon. What's the weather like?
It's the heights of summer, mate.
Heights of summer, February. Yeah. Okay, that's right. I was trying to
be fantastic.
Remember. Okay. Yeah. All right. Any other questions you have, Simon?
Nope.
All right. So yeah, I guess the cat's out of the bag on unified communications for Tectonic, and so this is kind of an interoperate with an article that we wrote for Audio Express. so people can get some cues from that and then get some more color from this conversation here today. So I just want to thank Tim, as always. Great guest to have and talk about all this exciting BMR technology. And so thanks for that. And
thanks, Tim.
Simon, yeah, thanks for joining. And of course, everybody, please hit like and subscribe. It helps us out, and share our stuff. And if anybody has any questions, just hit it in the comments below. We look forward to seeing those questions. So have a great day.
Thank you very much, guys. Thank you.